Roman the Science Guy. Part 3.
Hello, my name is Roman the Science Guy, and welcome to my show. Today we'll be learning about naming elements. For example, Mg oxide, which is Mg, has a charge of +2, and O has a charge of -3. And both the charges switch, which leads to Mg3 and O2. The reason why Mg has a charge of +2 is because Mg on all the elements on column 2 have a charge of +2. And O has a charge of -3 because O and the column 16 are charges of -3. Another example is boron, fluoride. Boron has a charge of +3 and fluorine has a charge of -1. The two charges switch to become BF3, which is boron trifluoride. Example 3. If two elements have the same number charge, when they switch, it cancels each other out. As you can see here, with sodium fluoride, sodium has the charge of +1 and chlorine has the charge of -1. The charges switch, as you can see, but they cancel each other out. So instead of Na1 and Cl1, they become as NaCl, which comes out to sodium chloride.
And now an important message by Alain Roman.
And remember, kids, always recycle.
And now we are back.
Next, we will be talking about
What is ionic and covalent? The ionic electronegativity value is from 1.7 to 3.3. Ionic bonds are usually non-metal and metals. In the periodic table, the blue represents the metals, and the yellow represents the non-metals. Electronegativity measure of how much an atom wants an electron. Say you use calcium and chlorine. Because one is metal and one is non-metal, it is ionic. Electronegativity's number scale between 0.7 and 4.0. If the number is high, it means it wants an electron more.
we're learning about covalent bonds.
Okay, so now that we know about ionic bonds, it's time to learn about covalent bonds. Okay, so now that we know ionic bonds are from 1.8 to 4.0, the covalent bond electronegativity value is from 0.0 to 1.7. Covalent bonds are nonmetals and metalloids. The purple outline elements will be the metalloids. There are two types of covalent bonds. There are covalent polar and covalent nonpolar. One type of covalent bond is called polar. Its electronegativity is from 0.3 to 1.7. And the other type of covalent bonds is nonpolar, and its electronegativity is from 0.0 to 0.3. Nonpolar has lower numbers, therefore it has a low difference. So covalent the polar bonds, which are, as we know, from 0.3 to 1.7 of their value electronegativity, they share electrons unequally. Here is a diagram of bonds sharing an electron unequally. Covalent nonpolar bonds, which have an electronegativity of 0.0 to 0.3, share electrons equally. Here's a diagram of two bonds sharing an electron equally. Okay, let's review. So ionic bonds are always metal and non-metal. And ionic bonds are always solid elements, which are from 1.7 to 3.3, and one atom gives an electron to another. Finally, ionic bonds are always between two elements. Covalent bonds are a mode of two nonmetals or metalloids, covalent bonds are solid, liquid, and gas. Because of the low value of electronegativity, which by the way is 0.0 to 1.7, it has a low melting boiling point. Always remember covalent bonds share electrons, and finally, covalent bonds are between two or more electrons. Oh, I almost forgot. One more thing that I might add, always remember that covalent bonds will use prefixes when naming two elements, such as mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. For example, carbon and oxygen, when put together, is CO2, and because it's covalent, it's called carbon dioxide. Don't forget your di or your IDE. And of course, after naming every element, add IDE at the end. Another example will be hydrogen and oxygen. When put together, it's H2O. And it's called water or dihydrogen monoxide. Don't forget your di or your mono.
Chemistry break. An atom says to another, I lost my electron. Are you sure? Yes, I'm positive.
Nine, 8, 7, 6, 5, 4, 3. We have ignition. 2, 1. Whoa! Whoa! Beautiful. 9, 8, 7, 6, 5, 4, 3. We have ignition. 2, 1.
Okay, so the pressure is going in from the pump into a little hole in this big chamber, the big black thing. And what's going to happen is it's being held up in there, and with this sprinkler valve, the valve is going to open and it's going to release all the air into this one chamber, which is going to therefore lift the rocket up.
Thank you for watching my final edition of Roman the Science Guy. Thank you. And remember, kids, you can't get anywhere unless you start in chemistry.